Good morning friends. In this chapter of semiconductor electronics we discuss about the half wave and full wave rectification and also the filter circuit. To convert whatever the rectified voltage we obtain, in this rectified voltage the some part of the AC is also included. Therefore, the output voltage of a rectified voltage is not constant with time. It means there is not a pure DC. So the some sign component are also included in output of rectified voltage. To remove this AC component, that is known as the ripple, to remove this ripple from this voltage, we are using the filter circuit. Now, after the study of PN junction diode, the question arises in our mind then, what is the application of PN junction diode in our daily life? For that purpose, we are going to discuss about actually the application of the PN junction diode. Here the diodes, according to their application, it's a different name, like as the photodiode, solar cell, light emitting diode. At present, at each and every step, we are using this PN junction diode. So, before starting our discussion about the different type of the diode, what is the optoelectronic devices? What is the optoelectronic devices? These diodes are also known as the optoelectronic device. Because in this type of the PN junction diode, the light is used. Light is used to produce the electron hole pair. So, as a result, the conduction of electricity takes place. Already we discussed in photoelectric effect. When the light or the radiation with sufficient frequency, that means the more than the threshold frequency, incident on a metallic plate. So this light, that means this photon, incident photon, having the energy HF. Photon is known as the amount of quantity of energy HF, that is known as the photon. When these photons are absorbed by the electron of the metallic plate, so electrons are emitted from the metallic plate. These emitted electrons are known as the photoelectrons, and also whatever the current flowing in the circuit, that is known as the photoelectric current. Already we discussed in earlier chapter the same working of photodiode. But the photodiode is working on the base of the photoelectric effect. Okay, first we are going to discuss about what is the optoelectronic device, right, and give the name of this optoelectronic device. What is the definition of optoelectronic device? The devices in which the photons or the photoexcitation generate the carriers due to the photons. The device in which, due to the incident of the light, the photocarriers or the electric carriers are generated or the produced. Such devices are known as the photoelectronics or the optoelectronics. Again, the definition of the optoelectronic devices is that the devices in which the photons generates or the generated carriers due to the photons. The device in which as the light incident on it, that means the photons are incident on it, which generate the charge carrier due to the incident photon. That is known as the optoelectronic devices. Again we repeat it. The devices in which photons generates the carriers due to the photons. That is known as the optoelectronic devices. Now, which devices are the optoelectronic devices? First is the photodiodes. Photodiodes used for the detecting the optical signal, that means the photodetector. In past, before the invention of the camera, at present we are using in our daily life. At that time the photodetector are used. Right? At present, the application of the photodiode is not used. But in factory and also the industries, the photodetector are used for the anti-smoke alarm, anti-theft alarm. This type of the devices are constructed by the photodiodes. Okay. Now the optoelectronic devices are, first is the photodiodes, used for detecting the optical signal that is known as the photon detector. Second is the light emitting diode, LED. At present we are using the LED bulb and LED tube lights in our house. When the book is written, at that time there is the new concept of emission of the light energy from the electricity. Right? Okay. So at present we are using the LED bulb and LED tube. At that time this type of the diode are used, and also just in past Diwali we are using the color cells. At that time what are the bulb are used? That is the LED bulb. There is also this type of the PN junction diode. Now the light emitting diode, that is the LED, which converts the electric energy into the light. Electric energy is converted to the light energy by the light emitting diode. And third optoelectronic device is the solar cell. At present we are using to produce the electricity at our home. In case the panel, solar panel, right? By constructing the solar panel on the terrace of our house, we can produce our electricity. So at that time, this solar panel is formed by the solar cell. In solar cell, the PN junction diodes are used. Okay. Now there is known as the photovoltaic device. Other name is solar cell, which convert the optical radiation light into the electricity. What is the principle of the solar cell? Solar cell converts the optical radiation, that means the light, into electricity. Here is, so there is the brief information about the optoelectronic devices. Again, what is the optoelectronic devices? The devices in which the photon generates the chaos due to photons. Optoelectronic devices are, first is the photodiodes used for detecting the optical signal. That is also known as the photodetector. Second is the light emitting diode LED, which convert the electrical energy into light energy. And third is photovoltaic devices, that means the solar cell, which convert the optical radiation, that means the light, into electricity with the electrical energy. Clear? So optoelectronic devices are three: photodetector, light emitting diode, and solar cell. Now we are going to discuss about the photodiodes. What is the construction and working of photodiodes? Right. Photodiode is also a PN junction diode, but for special purpose. The photodiode is special purpose PN junction diode. It is fabricated with a transparent window to fall the light on the junction of a diode. Here, this PN junction diode is fabricated in such a way that here the transparent window is given. So as a result, the light is incident on the junction of a PN junction diode. So what's happened? When the photodiode illuminated with the light, that means the photon, with the energy HF greater than the energy gap, EC, of the semiconductor, then electron hole pairs are generated due to absorption of photons. Already we discussed about the P-type semiconductor and N-type semiconductor. Right? And also we discussed about the conductor, insulator, and semiconductor. Here the two band, conduction band and valence band. The energy difference between the valence band and conduction band is known as the band gap energy. To move the electron from the valence band to the conduction band, it requires the energy more than the band gap energy. Clear this? Okay. Now here, when the photodiode illuminated with light, that means the photon, with energy HF, greater than the band gap energy easy of the semiconductor, then electron hole pairs are generated due to absorption of photon. Whatever the light is incident on the junction. In the junction, the electron or what are the covalent bonds already present in the junction absorb this energy in form of photon HF. When the energy of the absorption absorbed by the electron, when the energy of the electron is exceed then the band gap energy. So at this time the covalent bonds are broken and whole electron hole pair are generated. This generation of electron hole pair takes place due to the absorption of photon or the incident light. Again we repeat it. What's happened? When the photodiode is illuminated with the light or the photons with the energy HF is greater than the band gap energy for the given semiconductor. When this HF is much greater than the band gap energy for a given semiconductor, the electron hole pairs are generated due to absorption of incident light or the incident photons. Clear this thing? Okay. Now, the illuminated photodiode in reverse bias is shown in the figure. So, reverse bias connection is required for the photodiode because there is the p-type semiconductor is connected with negative terminal of external battery and n-type semiconductor is connected with positive terminal of a battery. So, photodiode always used in reverse bias condition. The symbol of the photodiode is shown in the figure. The symbol of a photodiode is same as the p-n junction diode. But here, this part is additional. The incident light is shown on the p-n junction diode. So without this arrow, there is the symbol of p-n junction. It is shown with the arrow. So that is the symbol of photodiode. If this arrow is outside, outward direction, so there is the symbol of solar cell. There is the symbol of solar cell. Okay, we discuss later. First, there is the symbol of photodiode. In photodiode, symbol of the p-n junction diode plus the incident light must be fall on the p-n junction diode. Okay, what is the working? How it works? There is the concept how the electron pair, hole pairs are formed. As the light is incident on it, then the energy HF is much greater than the band gap energy. So the electron hole pairs are generated due to the absorption of light. So how the photodiode is worked? The photodiode fabricated such that the generation of the electron hole pair takes place. So there is the fabricated, that means the prepared in such a way that, so as a result, the electron hole pairs are generated. In or near the junction or the depletion region of the diode. So here there is fabricated in such a way that as the light incident on the junction, the electron hole pair are generated in or near the depletion region of a diode. Due to electric field of the junction, electron hole are separate before they recombine. So here, electric field inside the junction is already in this direction into P. There is the electric field inside the depletion region. Already we discussed about that. There is the potential barrier. So as the light incident on the junction, so electron hole pair are formed in or near the depletion region. So here, electric field inside the depletion layer in such a way that, so what are the electron hole pairs are formed due to the blockade of the covalent bond get separated before they recombine. Before they recombine, because the hole has the tendency to take the electron. So here the electron hole pair are formed. So electric field in such a way that, so before it combine, so this hole and electron get separated. The direction of electric field is that the electron exits in inside and hole which is p side. Therefore, electrons are collected in p side and hole. Electrons are collected in inside and hole are collected on p side. So what are the hole and electron are generated? So they are exits in this direction. Hole in p side, electrons are in inside. So electrons are collected in inside and holes are collected in p side. So here reverse bias with the external vector is connected. So this electron are attacked by the positive terminal of the external vector and holes are attacked by negative terminal of the vector. Therefore, the holes are traveling in this direction and electrons are traveling in this direction or going in this direction. So as a result, when the load is connected with the P and N side of the semiconductor, so current flows in this side. Current flows in the side. Again, the direction of electric field in such a way that, so what are the electron hole pair are formed in junction due to the local of covalent bonds. So electrons are moves or the edges in A region while the holes are moving in P side. Or in other words, the electron collected by the A region and hole are collected by the P region of the semiconductor. Now, due to the external vector, so electrons are flowing in this direction as the load resistance is connected with PN junction, and holes are flowing in this direction. Therefore, the current flows. Photodiode can be used as a photodetector to detect the optical signal. So, that is the main purpose of the photodiode to detect the light is incident with the particular frequency of the particular wavelength photon. That means that is known as the photodetector. So photodiode can be used as a photodetector to detect the optical signal. The characteristic of the photoelectric, the photocurrent increases with the increase in intensity of light. Already we discussed this characteristic in photoelectric effect. As the intensity of the incident light increases, so number of the photoelectrons generated from the metallic plate also increases. That means the photoelectric current increases. So here the same thing, the photocurrent increases with the intensity of light. The IV characteristic is shown in the figure. Here there is the PN junction diode, reverse bias is used. Therefore, reverse bias characteristic of PN junction diode be the characteristic of photodiode. Therefore, the characteristic of photodiode takes place in third quadrant, I versus V. Here there is a reverse bias, therefore the current flowing to the circuit due to the minority charge carrier. Therefore, there is in milliampere. So as the voltage increases, negative voltage, so current up to the certain value increases less, then becomes the constant. As the intensity of the incident light increases, so current also increases. That is shown in the graph of electric current versus voltage, and that is known as the characteristic of photodiodes. Right? Now, what is the application of the photodiode? It is used in CD player, computer, and security system. Now, in CD player, we insert the CD or the DVD in drive. So, how the data is being obtained? So, whatever the data is stored on the CD or the DVD, that is in optical form. That is in optical form. To read this CD or the DVD, the optical instrument or the devices is required, and this optical devices is the photodiode. So when you open the CD drive or the DVD drive, at the time the one LED is given. So the position of this LED is linear motion take place according to the rotation of our CD. So position of this LED is or photodiode is take place like this way. CD is rotated like this at the bottom. So photodiode read the information from the CD or the DVD drive, and also in computer and security system. Clear this? So that is the photodiode. Again, what is the photodiode? Photodiode is special purpose PN junction diode. It is fabricated with a transparent window to fall the light on the junction of the diode. When the photodiode illuminated with the light, that means the photon with energy HF greater than the band gap energy EZ of the semiconductor, the electron hole pairs are formed due to the absorption of light. Right? The illuminated photodiodes is shown in the figure. Its symbol is this. Symbol is same as the symbol of PN junction diode, but here additional part is incident light, also mentioned in the symbol. How it works? The photodiode fabricated such that the generation of the electron hole pair takes place in or near the depletion region of the diode. Due to the electric field in the junction, electron holes are separated before they recombine. So here the electron hole pair are generated near or in the depletion region of the diode. So here the electric field in depletion region is in the direction such that, so what's happened? So they are separated before they recombine. The direction of the electric field is such that the electron exists in A region while the hole exists in B region. So as a result, the electrons are collected in inside and holes are collected in B side. When the external load is connected, so this hole and electron, actually these are the minority charge carrier in particular semiconductor, are flowing in outer circuit and constitute the electric current. Photodiode can be used as a photodetector to detect the optical signal. Photocurrent is increases with increase in intensity of incident light. The characteristic, IV characteristic is shown in the figure. So as the intensity increases, so photoelectric current or the photocurrent is also going to increase. The usage of the photodiode is in CD player, computer and security system. So that is about the photodiode. Now we are going to discuss about the light emitting diode, LED.